Hello everybody, my name is Mohit Deshpande, and in this video I want to show you guys how we can use contour detection in OpenCV. So I have our code here that does our things with binary thresholding, but now what I'm going to do is actually instead I'm just going to consider the image with the wallet, and we'll see if we can try to threshold and get some contours off of that. But actually what I need to do is, because I want to draw the contours on, I'm actually just going to call this image here and not convert it to grayscale. I'm going to have a separate version called gray equals cv2.cvt color, and then pass in the image, and then pass in, what actual color space I want to convert to, so it's color bgr to gray. Okay, so now that when I have this, then I can actually apply my thresholding operation, but I have to apply it on the gray version. So let's actually see what this looks like first before we continue, to make sure that everything's okay and we can actually detect that that contours there. So yeah, you can see that, yeah, it's pretty nice here. Okay, so now that this is good, we can actually try to detect contours, and then we can actually draw them on the original image. So to detect contours, we have to call cv2.findContours. We pass in the thresholded image, and then we have our parameters. We have first our parameter, that retrieval mode. So that always starts with retr, and then what kind of thing that we want to retrieve. In this case, a list is perfectly fine. Then the other is the approximation method. So I'm going to use chain approx simple so that we don't return a ton of points. And then we get two things back. We actually get the contours back and then the actual hierarchy back. But I'm going to just use that as a throwaway variable because we're not really going to look at hierarchy at the moment. But now that we have our contours, we can actually draw them on our image. There is an OpenCV way to do this using cv2.draw contours, and you pass in the image that you actually want to draw on, and it's going to change the image. So we'll use img, and then we have to pass the contours that we want to draw, in which case are contours. Then the other parameter is which of these contours do we want to draw. And if you put -1, what that means is that we're going to draw all of them, which is what we want. And these next two parameters deal with what do we want the drawing to look like. So in here is going to be a tuple. Since img is a red, green, and blue image, we can supply a tuple with 3 values that are in the order bgr, so that we can pick what color to draw them. I usually like to use green, and so this is like pure green, right? So B is 0, blue is 0, green is all the way to 255, and then red is 0. It's sort of like a really bright neon green, you'll see it. And then this last is what's the thickness of the brush that you want to draw the contours on, and 2 or 3 is just fine. Whoops. So anyway, this will actually modify the image itself, so we can just render this image. So let me run img, and let's actually see our contours there. Okay, so you can see our contour, and everything in green is kind of the contours here. So we have one contour here that kind of covers the wallet over here, and kind of get a little bit of this area here because this is the shadow. And then you see it kind of goes around the wallet fairly well. But there's this noise here, like it's detecting all these smaller contours here, which is not really what we want. It's detecting some stuff here, but that's not really that important. But they're all, again, it's also kind of small contour stuff small contours that we don't want to detect. So a common solution to this is actually right after we threshold, we also apply some blurring. So we do something like thresh equals cv2 dot Gaussian blur. We pass in thresh, the size of the blur, and then the standard deviation stuff. But the blurring is common to do before we use fine contours, so that those small, tiny little, random noise contours is actually all like smoothed out. So we can see the effects on this if we run it again. You see, then this looks much, much cleaner. because now all those little contour flecks were all, they're all gone, and we get, one contour here, and there's like a few little contours here. So what we can do is we can try to change up our blur and make it like something like a 7x7, and then when we do that, then we get, a decent contour here. Now the thing to note is that the more that you blur it, you do get rid of the smaller features, but you can see that now we're a little off on this contour, right? So look at this. So just keep this contour in mind. And now let me go back to the 5x5, and then you see that this contour is actually a little bit tighter than the 7x7. But usually, again, this is just sort of like a preferencing. Honestly, if there's some stuff here, then it really doesn't matter. In fact, because let me open that up again. Because you see that this contour is actually inside of this contour, maybe we can use that external mode to try to just get this top level one. So let me change retrieval list to external, and let's try running this now. There we go. Now when we run it, we get just a single contour, and that's a contour of the wall. There's a little bit of shadow here, but mostly it's a very tight fit to this contour, and we were able to extract this main contour here. So that's where I'm going to stop in this video, and just to do a quick recap, when we want to detect contours, we just call a single liner called find contours. We pass in a thresholded image, and actually what I've done here, in addition to thresholding it, is I've applied a little bit of blur. I've applied a blur filter, so we can kind of smooth out any of the small image noise that we kind of get from taking a picture. Then I have my retrieval mode to be external, so that I retrieve only the top level contour. And then I'm using this approximation method, this chain approx, so that we can, minimize the number of points that are in each contour. We don't get all the points, like if they're on a line, then we just get the endpoints of the line segment. So that's what find contour does. If you do give it if you say like tree or something, then you can make use of this hierarchy parameter, but we're not actually going to use that. Then to actually draw the contours, OpenCV also has a function to do that called draw contours, and the parameters are the image that you want to draw on, and it's going to change the image. We don't get a return image back, it's going to change this image itself. The list of contours that you want to draw on, and then which of these contours do you want to draw. If you just put -1, then it'll just draw all of them, but you can change this to be an index inside of contours, so you can choose to only draw like the first or the second or the fourth contour or whatever. But what you can do is, after that, then this all defines how you draw the contour. So in this case, I'm saying, because IMG is an RGB image, I want to draw in pure green, or like that neon green, so that's BGR, so this G is going to be green, and then 2 is like the width of the brush stroke that I want to draw on. So then this will draw an image, and we can see the result, and it draws the contour that, let me show the result, it'll draw the contour that will be the topmost contour here, and you can see that it fairly accurately detects the wallet. So this is how we can detect and draw contours in OpenCV.